Let us take a moment to visit Big Corona at sunset, because we no longer can visit Big Corona at sunset. If you're watching this 50 years in the future, our beaches were closed today, so that's my 10 seconds. Let's get on to 7 circles. We're on lesson 11 now, so we are coming down to the end of this just about, but this is a whole new ball game right here. This is a whole new deal. And if you don't know what we mean by deal, here's the deal. A radian. Big word. We told you that was coming. The radians are coming. The radians are coming. It's a new way to measure an angle, and it's all defined by the radius and the arc length. So that's our big deal. So we're starting with the learning target of, I understand that a radian is another unit of measurement for rotation in a circle. And we kind of define it as a fraction of the circumference of a circle based on a reference angle. So there's kind of a little bit of, some of these, it's going to compare. We can refer to degrees when we use that. I'm not using that term reference angle correctly here, but it's a reference to something we already know is what I'm talking about. And we also understand that a radian is defined as an arc length divided by its radius. That's actually what it is. That's the definition technically in this textbook, so we're going to use that as well. So let's take a look here. This is practice, so we're going to go right to 11.1. This is the lesson. It says a circle has a radius of 1 unit, and that's kind of important. 1 unit. You're talking about what we call a unit circle. There's my radius of 1 right there. So that's a bad one. Let's make a better one. Okay. So what is the actual arc length? I mean, if you go all the way around, the circumference there is going to be pi times the diameter. So it's going to be 2 times pi times the radius. That actually is the definition of circumference right there. But if we divide that by the radius, we would end up with just 2 pi. That's kind of the whole point of this. That's actually, I just defined a radian there. But let's go with arc length here and say, how about 180 degrees? Let's talk 180 degrees. What does that look like? So if I go straight across, oops, that's not a good way to go across the circle. Straight across the circle, I have gone a rotation of 180 degrees. So instead of going 2 pi times around the circle, I've actually gone 1 pi. So 180 degrees is kind of defined as pi. If I've gone 45 degrees, let's check that out. What does that look like over here? About like this. Well, if pi is halfway around the circle, that is actually 1/4 of that. So let me draw in my quarters here so I can do a little more in depth. So I can say, well, that's pi right there. Hold on, I don't want to use baby poop brown here to write in. That's pi right there. Then that means over here, that's pi, it's 1/4. So it's actually pi over 4. And that's the distance around the circle, the circumference divided by the radius. You notice how we're not putting the r in there because we've divided it off. 270 degrees, let's go a little further. That's all the way around, 3/4 of the way around the circle. And now we kind of should probably go back to actually 90 degrees for a moment. Let's do that, because 90 degrees is really pi over 2. It's right up here. So if pi is 180, remember, pi is 180. Just remember that. Pi is 180 degrees. You're going to want to have nightmares about that. That's okay. You'll wake up someday and you'll be fine. So pi is the half circle. That means that 90 degrees up here is pi over 2. So you notice how we're doing this? We're kind of saying if half a circle is pi, 1/4 of a circle is half of that, and then half of that is pi over 4. So 90 is equal to pi over 2. And then we can kind of reference that. This is what I mean by reference angles today. You're referring to something that you already know. So you're going 1/2 pi, 2/2 pi, that's pi by the way. And then down here at 270, you're going, that's 3/2 pi. So that's 3/2 times pi. Or as some people write it, 3 pi over 2. It doesn't really matter. Seriously. No, seriously, it doesn't really matter. 3/2 pi, 3 pi over 2. I like 3/2 pi. I like the fraction of pi. That's my preferred ding-ding method. Okay, and then we can go to 225. Where is it? Good idea to get these references. Like I said, 225 is really 180 plus another 45 right there. So we've got all these angles going on here. So 225 is kind of right here if you're watching the pen. But we're talking about that as radians. So we're going to literally go 1/4, 2/4, 3/4, 4/4, 5/4. That's what that is. That is 5/4 of the way. It's a little more, oops, wrong pen. It's a little more than pi. It's 1/4 past. So it's almost like telling time. This is really kind of a pi clock. And if you ever come back in my room, you'll see on my wall, a lot of these expressions are on the clock for different numbers. So that was, what did we say, 5/4 of pi. And then 360 degrees, obviously, that's all the way around the circle. That's right here. That's the full inch, the whole enchilada, the full Monty. That is a total of 360 degrees. That is 2 pi. So there you have it. Some expressions for pi. And what we call these, we call them radians, not degrees. So they're measurements of that rotation, or angle measurements, but it's the circumference divided by the radius. So in other words, if that circle got bigger, doubled in size, well, the radius would double, but it would cancel out in the calculation. So these are called radians, not degrees. But they have a partner. It's just a different numbering system. So we can kind of see here that even if the circle gets bigger, look at this little guy right here, this little circle right here, that radius and the arc length, you can kind of see those. It's going to be proportional no matter what. And that's the central angle is the same. And that's kind of what they're talking about here. In other words, L to R is the same thing as capital L to capital R. They're proportional because circles are, don't forget it, similar. So that's kind of the idea there, a constant ratio. It's constant no matter what. So in other words, the angle theta there is going to be constant if those circles are proportional. But that's a little here nor there. Let's just take a look real quick at a radian. Here it is. The radian is, in this case, what they're really looking at, it's the arc length divided by the radius. Because what they're looking at, when you talk about arc length, you're talking about, this arc right here. Let's say this arc length was, in this case, let's say that was pi over 3. And then you divide that by its radius here of 1 unit. It's pi over 3. If that circle gets bigger, the book kind of goes a little sideways on this. And we're not really as concerned with the arc length and the radius definition of radian. We're more concerned with the fact that you understand what it is. So here's a little quick demo. If you were in class, you would have seen this done live. Since you're watching a video, it's not quite live, but what happens is this little radius here, this little bit radius kind of sneaks out of here. He takes a left turn and he starts going out into the circle. The radius is becoming the circumference. So once I get one full radius, that's one full radius right there. That is the angle is actually 1 radian. And that's because that's exactly what's going on there. And if we keep going, you go out all the way over here, you get to pi. Because what do you have? You have 1 radius, 2 radiuses, radii, sorry. 3 radius, I just can't stop saying radiuses. It's so much fun. That's 3 radii. And a little over here, it's kind of the 0.14 blah, blah, blah. I don't memorize pi out because there's no point in it. But that is that actually is 3.14 radiuses around the circle. Or as we say, pi radians. Because even if the radius was 5, we would be taking 2 pi r, taking a fraction of it, the arc length, and then dividing it by 5. So it wouldn't matter. So that's why we kind of always usually say, we call this a unit circle. We usually just work with a unit of 1. It's easier. And then if we go all the way around the circle, let's finish it off. There it is in all its glory. That's 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and that's a little 0.28 there. 6.28. Don't forget that number. Write it down. Put it in your phone book. I don't know. That is 2 pi radians. That's what that is. That is a full 360 degree turn around that circle. Let me make that even more emphatic. That is 2 pi. And that is the same thing as 360. And what's pi? Pi is the same thing as 180. Don't forget that. That's going to be our conversions, guys. We're going to use pi over 180 as a way to convert these things. So that's the idea. Radians, it's a measure of an angle. It's really just a fraction of pi. If you can really use pi as a benchmark, and I know that Weihart says pi is wrong because she says that pi is half a circle. Why is pi half a pi? I know it doesn't make sense, but the Greeks were not talking about food here. They're talking about math. So even if you're hungry and pizza sounds really good right now, because it does, let's move on. All right, so there it is. Pi is 180. That's your benchmark. And if you want to go a little further, you can go a little further and go up to pi, oops, not that pen. You can go up there to pi over 2, right there. That's half a pi. You can go to a quarter pi, pi over 4. You can go back down here to 1.5 pi, 3/2 pi. And you can get all these benchmarks. There's 30s, 45s, 60s. That's the next lesson, where we get a little more familiar with our fractions of pi. Bottom line, end of story. You need to be able to know that 180 degrees is pi radians. That's the big, big, big news. And then you know what a radian is. Now, if we can get more familiar memorizing some of the common values, that's great. But that is a little more of the next lesson. So it's 11:24 on the clock. We're going to stop it right there. And in traditional style, except we're doing it on this page, because no one ever probably looks at the next page. I don't know. Comment if you watch the whole video and you always see this page. I miss Forbes. Forbes, we miss you. Know that. Actually, we miss all of you. We really do. So 11:48 on the clock. Let's call it right there.